Hello, my name is Ryan Beam, and I'm a student at the University of Kentucky studying economics and statistics. In this series, I explore how data is applied in real-world settings and how the field is continuing to evolve across industries and roles. Today, I'm joined by Krates Ng, CTO at Unlearn.AI. Thank you so much for meeting with me today.
Oh, thank you. Thank you for having me. Hopefully, I
Yeah.
can be helpful.
Oh, I'm sure you will be. I'm looking forward to our conversation. So, kind of starting us off, I know you've had a very interesting and amazing career so far. I know you started out kind of doing some cool things, building web analytics in the 90s, co-founded a healthcare AI startup, excuse me, to now leading a team as a CTO. Could you kind of walk me through, some of maybe the big moments across your career and how this amazing career has kind of laid out in front of you?
Sure. So your podcast is about data, AI. Is that true?
Yeah.
So I I wouldn't think I'm drawn necessarily to data and AI because it framed as if I can see a trend and I chase it. I wasn't that smart. What pulled my career forward is simpler than that. I just wanted to solve meaningful problems, um, master the craft of building technology that actually matters.
Mm.
And like you talked about Andromedia, my first job coming out of school, um, the problem solving is web analytics. Like at the time, there's no Google Analytics, they barely Google at the time, like in the 90s, in the dot-com days. But now that you look back, it's a data problem,
Mhm.
right? But I didn't look at it that way, right? We look at it, okay, it's an impactful problem to solve and then a problem in front of me, right? And that kind of repeat itself because at the end, what I try to do is follow the work that is most consequential in the industry, put myself where the action is,
Mm.
and be around people better than me. And I'm very lucky. I ran into a lot of people who I continue to admire and learn from. I think um, that is a crucial if I'm giving advice to people who are early in their career, um, not to not to chase label. Like,
Mm.
because right now AI is very big. I've been talking to youngsters like it might be more productive to not think about AI as a vertical.
Mm.
Like think about it. Like it's not an industry you go into like finance and healthcare, like or fintech or health tech. AI is like almost a new way for us to think about how we build, operate, and scale solution that we build, right? And data is the backbone of it, like acquiring the right data, how to clean it, how to harmonize it across different data source and standards that we got it from. I think that area is the foundation, or machine learning just won't work.
Right.
So a lot of companies call themselves AI. Um, some genuinely are, like including Unlearn, where I joined a year ago. We're building foundational model and infrastructure. But are we really selling AI? We're selling better clinical trial outcomes. AI is the engine, the value, like, but still the value is the domain, like
Mm.
the understanding the science, the regulatory landscape, the customer's workflow, decision making, and the data. Then if we strip those up, AI won't solve anything. So
Right. That's very interesting. And I think a very powerful distinction there, kind of as looking to the future, especially as someone that's, I'm still in the middle of college when everything feels like it's changing so extremely fast. Um, it's hard to navigate where to put your chips in the stack and what kind of skills or what areas are going to be worth focusing in on. So thank you for that. I think that's really powerful perspective and kind of moving off that into some of the kind of steps along your career. I know you co-founded CliniCast, which, to my understanding, worked with machine learning models and predicting outcomes and helping with clinical workflows. So I was just kind of curious, especially at that time, and what does it take to get a doctor to actually trust, a prediction within their decision making, especially, at the time where some of this is even more modern and new than even it would be today.
right. I mean, I have a genius of a co-founder on the science side, so that makes things easier. Naturally, there are. a validation of our model, the sensitivity and specificity. I further build that learning with my experience of RapidAI. Uh, um, I think to talk about convincing the doctor to trust our model is more interesting to talk about, are we providing the right information in front of them at the exact moment when they make that decision? And is those information relevant? And the credibility, like in Rapid, we have to go through FDA.
Mhm.
So the fact that FDA is approved, that means that they are well proven. That makes things easier, right? I think one to further that answer, I think let's talk about it's similar in CliniCast. A RapidAI is fresher for me because CliniCast is over 10 years ago. But similarly, we really try to understand the workflow of our customer. Um, for RapidAI, when we first took over the team, that we have the best model. It take a brain scan of a stroke patient that hit ER, right?
Mhm.
Imagine a stroke patient go to ER to do a brain scan, and someone have to make a decision whether to ship this patient in ER of, say, San Francisco General Hospital.
Mhm.
Should we ship it to Stanford Hospital, where the surgeon is there to clear the clot so that the blood flowing again, so the patient can walk the rest of his life? Right? Should we move it, or is it too late? If it's too late, we make that decision. We incur a lot of cost, add more risk to the patient. Is it worth it to make that decision? Now, who make that decision? We have a model to help take the brain scan and identify which part of the brain is impacted by the clot and not getting enough blood. How much of it already dead? How much of it is not dead yet, it's still salvageable? Now, even we can build that model and we're the best.
Mhm. That's fascinating.
How does it work? The ER doctor might not, often not, particularly in a small hospital, have enough neuro expertise. Now they are hoping that the Stanford doctor will look at it
Mhm.
to make that call, but the timing is off. So
Mhm.
ended up what rather than just put more effort, spending million buying more brain scan from different sources and hiring neuroradiologists to $600 an hour to draw the scan, the label, so that machine learning can train rather than spending years and more to make it even better. We ended up invested into the workflow software.
Mhm.
Imagine that as soon as that scan come in, we run the model, we push it to the neurosurgeon of Stanford on his mobile app. We build this dotcom viewer on the mobile app, and the doctor may be on call having dinner in a restaurant with his family. He's looking, he's like, oh, I can save this patient.
Mhm.
Yes, it's worth it. Hit it, and the workflow will ping both sides of the hospital and the ambulance. And it's like, okay, I can leave now. I'll be back in 20 minutes. 20 minutes. Everyone know 20 minutes. We get the patient on the table. When the doctor come in, patient ready, wash his hand. 5 minutes late might be a difference between whether this patient can walk the rest of his life, right? So imagine such a workflow, that coordination, everyone, they can see who saw this, who still haven't seen it. They can see it so they don't have to call around. So have you heard about this, right? So just that significantly increase the value our AI model can create. Then us try and work harder to make an even better model, right? So of course, we can have a shitty model, but you see the power of what we learn is the understanding is still the same, whether it's AI or not AI. Understanding the problem is still the gist of it,
Mhm.
of delivering impactful technology.
Yeah, that makes a lot of sense, and that's very fascinating to kind of hear about. I don't have a lot of domain experience or understanding of some of the crazy technologies that have been developed in things like healthcare, where like you said, that's the difference in 20 minutes. Just a quick workflow can be the difference in somebody being able to walk, and so it's really cool that to hear that kind of impact being accomplished. And I think that kind of goes back to what we were talking about earlier into finding, those not necessarily chasing certain technologies, just kind of chasing where the impact is. And I think that's really cool to hear about. And I do kind of want to touch on that. You mentioned Rapid AI, obviously, and one of the things that I've read about you is that you helped scale the engineering team from from 10 to 80 plus people. So I was just kind of curious, what did that growth kind of look like?
Mhm.
Maybe that's just a day-to-day problem, and at a certain point, is that more difficult than scaling the technology itself?
Well, joining a startup, for those of you who are young coming out of school, well, first of all, I strongly encourage young folks to go to startups. That's that's where you can truly learn comprehensively.
Mm,
And to grow, to you asked about scaling. Why I pause is scaling. The first problem is we have to figure out how to scale the business before we have the money to scale the team. I mean, even the money is from raising money as a startup. It's only how much money you raise, right? So you have to achieve to a certain point to raise the next round,
mm,
right? So we have to first execute to get to certain level of success.
mm,
Then we can raise the next round. Then we can say expand it. And that's why we first have to execute before the scale.
mm,
Obviously, if I join the team that already have achieved that and they hire a new head of engineering to scale it, then is more convenient for me. Hiring people, scaling of the team is basically hiring people. Hiring people is a very important skill for engineering leadership. Um, at the time, right now, you guys are not as lucky as my generation or even a generation after my generation. In the last 20 years, there are almost always more jobs than there are engineers or data scientists. Um, so, and in that environment, hiring is a war. We are enticing for a lot of people who want to go to startups. It's a privilege. I mean, as a health tech, it's convenient also because it's a lot of people understand it's a privilege to work on technology that save lives.
mhm,
It's a privilege. Uh, uh, um, Hiring is challenging. To go one level deeper, amount hiring the right engineering leader who share and can help me drive the same culture and discipline and the bar of how good can be and continuously want to push that you can go even further. Uh, um, and I ended up finding myself rarely hire engineering manager, but to quickly grow my top engineers who are interested in that path to promote them to it
mm,
because they already understand our way. I think that's where the scaling on that belief, we struggle of having enough people want to be manager
mm,
and having people grow fast enough. If I have to scale very fast, then ended up you might have to hire engineering manager. RapidAI wasn't that lucky that we had that problem. I have friends who I admire who have to build a team so fast
mm,
to go to like from 50 to like 200.
mm.
Then you have no choice but to hire and push the problem to how to train this manager to make sure they can deliver the same culture, the same guidance, the same bar that we want to set based on what we care to measure.
Yeah, that's very interesting, and kind of want to touch on a point that you got at there of some of those people who, have to scale super quickly, have to scale these teams super quickly, and along that line of thinking, things are moving so fast that sometimes the motivation or the pressure to ship things super quickly
Mhm.
out the door is a lot. So I was kind of curious because I know that you're, no doubt skilled in understanding, the trade-offs between simplicity, meeting customer requirements, and the urgency to get something out of the door, while also not, maintaining all that technical debt of bad decisions or
Mhm.
rush
Mhm.
decisions along the way. So could you kind of just kind of go off that a little bit and maybe talk about an example of this in your own career?
Sure. I mean, every single company, the CEO, the product, the salespeople, everyone will come to you. Can you move faster? I Before we answer how to move faster, I often recognize and convey that okay, faster might not be faster because oftentimes is how we prioritize and how and when we choose to invest is the problem. Whenever you guys on the business side struggle and cannot decide indecision, oh now we have to move really fast, right? So I challenge them that, hey, you don't know what we should build until last minute, and now we have to build it in short period of time. Can you go faster? I'm like, well, can you research better so that you know sooner? Can you have the gut to invest earlier so that we can actually start working on it sooner? I think that is one element that I find myself speaking to the people who push engineering team to move faster. And then I will start explaining to them, of course we can go faster. They're a triangle, time, resources, and scope. In the middle of that triangle is quality, right? Now, we're never willing to sacrifice quality. There's a few quality. The four quality we talk about. One is the technology behaving the way we intended? Okay, the intended behavior, does it actually meaningfully solve the customer problem? And would the customer pay for this problem, right? This one is product management, business problem, right? And this one is kind of joint. We also own it. Don't rely on the business side or product to own it. We have to dictate it too. But then there's one more that is not obvious, which you touch on, is the TED debt, right? So how I explain to people is TED debt, it's like, it's not necessarily a bad decision. It's naturally, we're all naturally building TED debt. TED debt is the best analogy our team use is it's like dirty dishes when we cook. You have no choice but to accumulate it, right? Because it depends on your goal. A feature can be a TED debt if you look at it differently, right? So now the challenge of moving fast is it's like, hey, can you cook 5 dishes in an hour? Yes. Oh Lord, Ted Dad, to the point that my kitchen is packed with Ted Dad. I cannot cook anymore. Now, ideally, over the year, we continuously find the right balance between dishwashing and cooking, washing and cooking. Then I can actually deliver the most value this year.
Mm,
But yes, from time to time, because of different needs, I might optimize for that date, for that scope and that date. And then we pile it up and we clean. But we keep doing that. It feels faster, but the whole year I actually ship less,
mm.
right? But of course, you can always reduce scope, you can always increase headcount, right? Those are the point. So that's how I see it.
Right. That's very interesting, and I love the analogy you used in that example to kind of illustrate things. Because, like you said, technical debt is something that um, I mentioned it in that question, but it's something that I haven't thought too deeply about, and I especially don't have a ton of experience with it. Being in my stage of life. So, thank you for that. It's kind of cool to hear that perspective.
And the flip side is if you're not accruing technical debt, you're probably moving too slow.
Right. It's probably maybe it's a good sign then to kind of build that on, then at least it means
The
you're doing
technical
something.
debt is also there are good debt and there are bad debt.
Mhm.
So ideally, we do a lot of our work, a lot of thinking to avoid the bad debt.
Right. How do you how do you look at it and decide what is good and what is bad?
The bad ones are the ones that you basically limit your extensibility, and
Hmm.
you basically have to good or bad is not a definitive, clear black and white line. If, oh, next year, the upcoming potential of the business, those are the area we need to build. So then if we're not aware of that and we are optimizing for this, even though like the debt might not be that bad if we're building this, all of a sudden it become very bad building this, right? So then I have to rewrite it, then I'm wasting time, right?
Right.
So it also need to have the context of what is in front of us to to define what is good or bad.
Hmm. That's yeah. Wow, I really like that. Thank you for sharing that, and that's definitely something I'll be thinking about as I, reflect on this when I go through and think about some of the things you've touched on, and kind of moving off that into some of the kind of along with technical debt and how some of those things get a little bit complicated, deciding, what's black and white between, is this good or bad, worth building technical debt for this or not. So I know there's a lot of, complications in technical fields, especially. And I know you've been a part of a lot of different acquisitions. So I was just curious, as somebody who's worked within data teams, especially on the acquisition side, what happens to a company and what happens to the data team and the data when something gets acquired? And, has that been messy every time, or is it always a beautiful, crystal clear process?
Um, I think data are assets. So whenever acquisition happen, um, the data is always going to be in point value.
Mhm.
Um, whether how the due diligence before the acquisition closed, naturally, the acquirer will care a lot about um, the the detail of the clean ownership of the data
Mhm.
and how do we actually have the data in the shape that is fully in our control. That after the acquisition, a lot of integration, likely the data will stay where it is,
Mhm.
and then it will be integration to between different system
Mhm.
to access and process the data. So,
Okay, yeah, that makes a lot of sense, and that's very interesting because, once again, coming back to where I'm at in my stage in life, it's something I can only theorize about. So hearing it from you,
right.
it's interesting to see your
The
perspective.
data, actually, because data and technology without the context is also hard to make sense of.
Hmm.
Like I mentioned earlier, like we have clinical trial data of Alzheimer's disease. If you don't understand the Alzheimer's disease, and the biomarker and the outcome, you're like, okay, well, there's some numbers,
Right.
right? And so the domain knowledge and context and the handling of the data. That's why acquisition usually they will have retention incentive for the key employee and player to make sure that we the acquirer can continue to to leverage the value that the data and the technology deliver.
That makes sense. And kind of going off that into, talking about the domain knowledge, especially and understanding what's actually going on. So I was kind of curious because you've mentioned a little bit about your current place of work at Unlearn AI. So I was kind of wondering if you kind of clarify something that I've kind of researched about your company where you're working on digital twins being
Mhm.
built for clinical trials. So as someone who's not in that niche knowledge of healthcare and what a digital
Mhm.
twin is, could you kind of clarify some of that for me and why something like that matters?
Sure. Digital twins is the key thing in our context. So I am no scientist. We have a lot of geniuses, PhD and scientists in the company who go into a lot of detail of this. Um, Digital twins in our context is a comprehensive, individualized prediction of a individual specific patient's disease trajectory. Is not a regular like predictive model that have a score, have a specific number, or a population average. We literally build digital twins of individual real-world patients and predict their outcome under a controlled condition of different future point. A trajectory is generative. That's what it is. how does it create value? You have a concept of clinical trial. Clinical trial is, hey, there's a treatment, say a medicine for, we'll just talk about Alzheimer's disease. Um, and how do we know this work, right? So clinical trial is a very, very long process. Every single drug you see in Walgreens, the drugstore, like, ever have to go through such a long process for FDA to say that, okay, I believe it's safe and actually effective for that purpose, that I'm okay with it. You can sell it to our population, to our public, right? So there are a few phases, some focus on safety, focus on different part. The trial, phase three of a trial is particularly long and expensive. Imagine a trial of a Alzheimer drug. It might need a few hundred, say 600 patients,
Mhm.
300 in the treatment arm, meaning that they actually get the drug. 300 in, we call it the control arm, which they get placebo, like sugar pill, that they don't know that they're not. They don't know which one is this, is a blinded, a randomized trial. There's another type of trial called single arm trial. They only have the treatment arm. Why people do that? For example, if it's a late stage cancer drug, it's unethical to put people to fake it. Are you getting it? But you're not getting it. So right. So the two type of trial serve the same goal, but they are differently run differently. So how our solution is, we will help because it's all highly statistical, complex math, right? So what happened is we will build digital twins for every single patient on both arms
Mhm.
so that we can, like the treatment arm, we will build the digital twins to predict if you're not taking the treatment, what is this twin look like? And for the control arm, we also have the same thing so that you can see the gap and we can help statistically control and reduce the variance of the treatment effect. As a result, we either can reduce the amount of patient that is needed because statistically we're more sound, or we can improve the confidence level, the power of the trial without increasing patients. So this is with our mission or our goal of how can we help deliver treatment to desperate patients safer, faster, cheaper. So in single arm trial, they just have this the treatment arm. So the control, how do they compare with is to use literature, population average in general. That's how it's done to compare. Oh, it's kind of working. So we are able to take the treatment arm patient and we create a synthetic a control arm of the same human, but they are not taking the treatment. We predict it, and then we can show that this is the outcome. So this give them a higher confidence of the treatment effect.
Yeah, that's super interesting and kind of echoing what I was talking about earlier as how I haven't dove too deeply into, healthcare technologies, but that's just fascinating, hearing some of that work being done. And it's cool to see, just it's cool to see technology being used in such admirable ways as well. So I think that's always very fascinating to me, and it's cool to kind of hear you talking about that, especially that you've got to work on these really cool
It's
projects.
a privilege.
Yeah, absolutely.
Yeah.
Absolutely. And kind of as we move into our last couple questions that I have for you, I want to kind of circle back to an idea that you touched on a little bit earlier, and that's kind of the idea of, the values and data and context. So, when I was introduced to you, I was told that you had a strong perspective on the idea that, data infrastructure is a long way from being automated away. So could you kind of walk me through your perspective on that and where you stand in general? With kind of the current state of AI-driven innovation.
Yeah, I mean, don't get me wrong. I mean, like just Claude Code have changed our world. Holy, like the last 6 months, it changed so much of our world. How we build software is different,
Mhm.
and it's real. It does impact efficiency. Imagine I used to need like 5, 6 engineers on one work stream. For the same work stream now, I need two or three.
Mhm.
I mean, it pushes the bottleneck. to code review because it generates so much code. But let us rethink how we even approach software development, right? Because coding used to be the most expensive bottleneck. Now, code is generated. Now, verifying it and holding, like controlling it, the quality and making it actually scalable in a way, controlled way that you know how to maintain,
Mhm.
it shipped. Um, w- w- Data processing, and it's what we face is similar to from my assessment and my perspective of why, like 6 months ago, there's MIT paper that came out to say that, hey, all this generative AI, 95% of the company investing in it did not get any real value out of it, right? Well, at the time, the last 6 months also, the world have changed a lot with the um, what we see is individually is very helpful,
Mhm.
is very, very helpful. Uh, uh, um, but we know that ChatGPT and Claude, 15% is wrong. There are things that they're, wow, they're genius, and there are things that, okay, it's really dumb,
Right.
right? So the challenge is, let's say it's advanced, it's not 15, 10% is wrong, but you don't know which 10%.
Mhm.
So now if it's just my thinking partner and my assistant, anyway, it's okay. I can identify that and correct it. But if it's a workflow, then it becomes challenging,
Mhm.
particularly because most of the data process, so I mentioned earlier, like machine learning, AI, the backbone is data,
Mhm.
like taking a lot of data. Ultimately, if we distill to one sentence of what do we do with all this stuff, is we just taking data from yesterday and today and make better decision tomorrow.
Mhm.
That's really what we do. Like, right? It's the same as 30 years ago when there are data warehouse. It's also exactly solving this. Basically, that's what we do, right? So now there are a lot of data is not from different data source. We hire, and not just we, like a lot of companies hire a lot of strong scientists, PhD to process data, just cleaning data,
Mhm.
right? And to the point that it's ready for machine learning to learn, right? And this process is designed for human to do. It's
Mhm.
very human centric. So now, say there are 10 steps, step one, step two, step three, and we try to use, we have a lot of optimism, Claude, it's going to automate this shit. And when you actually go into it, what we found is there are three tiers of problem in our world. One is it's deterministic. Okay, for this data source, Claude, write this code, run it, we're done. Tier two, okay, not that simple, it's non-deterministic, but I'm moving this data from this data definition and to this data schema with ontology, with the rules. We know how to verify it.
Mhm.
Okay, you're gonna do some magic, but we can verify it. The third tier is very challenging. It's non-deterministic like tier two, but it requires human expertise to judge. Can we, is it correct or not?
Mhm.
Right? So then when we understand these three tiers, and then now we go back to the 10 steps of data processing that a lot of smart data scientists have to deal with. And then we found out, oh no, every step, tier one, two, three problem are already entwined together. We kind of see opportunity, but we just cannot automate it. Now, how do we solve this? We have to rethink this whole thing
Yeah.
into step A, B, C, and D, and step A might have different component of this, so that we need to isolate tier three so that we can maximize. And tier three is not forever tier three. There are things we can do to convert tier three problem because we have human labeling and create synthetic solution. There are a lot of technology trying to solve how to make tier three less painful
Mhm.
or convert it into the so I think that process require a lot of domain knowledge of the product, of the data you're dealing with, require a lot of rethinking. And like like most things, the biggest problem is people problem. now you're asking people to change. Oh no, right? So I see that. I mean, it's happening. Like we are going through this internally ourselves too, because we want to automate it, and it's not, it's not as easy as we were hoping
Mm,
because AI is not as magical as we're hoping. So that's probably that's probably what you heard about why I think that is not is not going to happen just like that.
mm.
Yeah.
Interesting, and it's very cool to hear your perspective. And I kind of touched on this earlier, where I'm in college, in the middle of college, trying to figure things out of what direction to go. And so, kind of hearing your perspective on that was, really valuable to me. And thank you for sharing that. And it's
I mean, I am encouraging folks to use more of it
right.
because the ended up you'll find yourself figuring out how oftentimes how do I verify it?
Mm,
How do I verify it systemically? As long as I can verify it systemically, we can automate it.
right.
When we cannot verify this systemically, rather than like keep thinking about how to like we have to rethink the whole workflow. Yeah.
Right. Because I've kind of been, I've definitely experimented with AI, and I use it every day, and try to keeping up with, the emerging technologies, that I have access to. I wish I had Claude Mythos or whatever was just, shaking things up. But on that front, like you spoke about the 10%, being wrong, is just a, an example of, um, making things correct and not knowing what is wrong. And the other day I ran into that where everything was running perfectly and Claude just, completely messed up something that it should, I would have thought was, an easy step of the process, that it was very easy to verify that that was clearly incorrect. And I'm like, how do you do
Right.
these insane things that seem so novel, and things that, I'd have to read 3 months worth of books and research to understand, but you can't pump out something that's, so it's interesting to kind of see that kind of gap that you were talking about. Um, so it's cool to see you kind of echoing that as well. And it's not just, me and my echo chamber in college running through technologies like that. So
Always create a lot of value for us, but I suspect most of us have written like quietly and not proudly written a prompt that holy shit, I just told you not to do this.
yeah, yeah, yeah. I think definitely just kind of getting enraged at a computer
Right.
is, it's not my proudest moment, but I'll definitely admit that it has happened. So, and kind of just going off that into kind of my final question, because you've given me a lot of great things to think about, and things that I could kind of consider as I go forward, and a lot of great advice. But if you're in my shoes, 19, studying economics and statistics, data science, trying to set myself up, in whatever crazy future this is going to look like, what would you kind of think about or focus on, or just kind of general advice would you give to me trying to build kind of a long-term career in that space?
Um, don't chase labels.
Mhm.
I do encourage startup, but more importantly, chase hard problem,
Mhm.
chase mastery, set a high bar, and put yourself in a room of people smarter than you.
Mhm.
Be around the best and keep chasing that. I think that it's a better target
Mhm.
than oh let me go to this few companies or let
Mhm.
me work on a company with AI on the name.
Mhm.
I mean you probably will still end up on some of those, but it happened that way. That's not your goal. Your
Mhm.
goal is to chase hard problem, impactful problem that you can be proud of. Yeah.
That's really great advice, and I really appreciate that. And that's definitely something that I'll think about and kind of ponder on as I kind of try to figure these things out and make these decisions. Because I know it's flying by. I'm almost a junior. I can't believe the workforce will be here before I know it.
Right, right. Because, life, of course, we need money.
Mhm.
I want more money.
All right.
But the true joy is like, other than love and family, is mastery,
Mhm.
just being good at something. And we can be good at like soccer and different sports or piano. Um, but but the thing we spend most of our time is still our work.
Mhm.
And that's why building our mastery on that is the true joy. Yes.
That's really that's very powerful kind of message there. And yeah, that'll definitely be thinking on that. So thank you for sharing, and thank you again for taking the time out of your day to speak with me. And I really appreciated the conversation.
Thank you. Thank you. Thank you for having me. It was fun.